All right, so we're looking at collinear points today and also using gradients, applications of gradients, let's say that. So if we look at collinear points lie on the same straight line. So in this diagram we have here A, B, and C would be collinear. They're on the same straight line. To prove that 3 points are collinear, what we do is we take the gradient between two of the points and we calculate it. And we take the gradient between the next 2 points and we calculate it. And if those gradients are equal to each other, then those points are collinear. So we know from yesterday that equal gradients would make lines parallel. But if you have equal gradients and the points you're working with have a common, so the 3 points you're working with, you're using one in common, that common point joins your 2 gradients together, making it into a straight line. All right, so I'm not sure if that was very clear, so let me show you with an example. So in the same example from the first page, if I want to prove that A, B, and C are collinear, what I do is I find the gradient of A, B. Okay, so I take A and B and I do my gradient formula. Okay, so we're going to have 5 minus 1 over negative 1 minus 1, which gives me 4 over negative 2, which is negative 2. So the gradient between A and B is negative 2. The gradient between B and C, okay, so I'm taking those 2 points. And we're going to have 1 minus negative 5, remember your bracket, over 1 minus 4, that's 1 plus 5, 6 over negative 3, which gives you negative 2. Okay, so you can see these two have got equal gradients. So what I'm going to say is therefore the gradient of AB is equal to the gradient of BC, and B is a common point. So you've got to have equal gradients, and on each of them you have to have the same letter repeated, a common point. Therefore A, B, and C are collinear. Okay, it doesn't matter. You could have taken the gradient of AC and made it and showed me it was equal to the gradient of BC. As long as this would have been true as well, you can use any point as common. It doesn't have to be the one that you think is in the middle. Okay, so you can use any point as common. All right, so sorry, that was proving that if we can prove that A, B, and C, if the gradient between the 2 points are equal and it's got a common point, that is proving that the points are collinear. That's how you prove collinear points. All right, let's look at using the information from parallel lines, perpendicular lines, and collinear points to solve some equations. So I've been given 4 points here. We're looking for x, it's missing there. And we're told for question 1 that AB is parallel to BC, which means that the gradient of AB has to equal the gradient, the gradient of AB is, we were told that the AB is parallel to CD, so the gradient of AB has to be equal to the gradient of CD. That is a fact. All right, so what we're going to do is we're going to work out the gradient of AB. Okay, so the y at A minus the y at B over the x at A minus the x at B. What is my gradient? It's going to be 5 minus 2 over x minus 3. That's going to give me 3 over x plus 3. And that's all I can do with that gradient. Now I'm going to look at the gradient of CD. What is the gradient of CD? Well, it's the y at C minus the y at D over the x at C minus the x at D. All right, so C and D are up at the top there. C is 5 minus 4, and then 2 minus 1, which gives me 1 over 3. Okay, so what do I know? I know these are parallel, so 3 over x plus 3 has to equal 1 over 3. Okay, so now we've got an equation. Just going to go up here. We've got an equation, so we need an LCD. So we're going to put both sides. So gradient of AB equals the gradient of CD. That's there. And now we need an LCD. And our LCD is going to be 3 and x plus 3. So both sides, or you can cross multiply. That's also going to work. It's up to you. Okay, so what I have to times this side by, I've got to times it by 3. And I've got to times this side by x plus 3. All right, so cross multiplication, finding an LCD, it's going to be the same thing. I'm now just going to multiply both sides by that LCD so that it cancels. And now I can solve it as a normal equation. So I'm going to have 9 is equal to x plus 3. And I'm going to subtract 3 from both sides. And I'm going to end up with x is equal to 6. So if A, B, and CD are parallel, that means that x would have to be 6. All right, then the next one says if A, B, and D are collinear. Okay. Okay, so we don't use the x from the previous question because they're actually wanting us to work out a new x if those 3 points are collinear. So if they're collinear, then the gradient of AB has to be equal to the gradient of BD. Okay, there's equal gradients and a common point for collinear lines. Okay, so gradient of AB, well, we've worked that out previously. We'll do it again quickly. So we've got 5 minus 2 over x minus 3, which gives me 3 over x plus 3. Okay, what about the gradient of BD? We haven't worked that one out. Y at B minus y at D over x at B minus x at D. So we have 2 minus 4 over negative 3 minus 1. So that gives me negative 2 over negative 3 plus 1, which gives me positive 1. Okay. If these points are collinear, then 3 over x plus 3 has to equal 1. All right, so let's give this a denominator of 1. And then again, we can either cross multiply or find an LCD. 3 is going to be equal to x plus 3. And then we're going to subtract. And we're going to be left with x is equal to 0. So if those points are collinear, then x would have to be 0. In other words, A would have to be 0 and 5. Okay, the last one was if AB is perpendicular to CD. Okay, so number 3. If AB is perpendicular to CD. Okay, so what do we know about gradients that are perpendicular? That means the gradient of AB times the gradient of CD has to be equal to -1. That's what we know about perpendicular lines. Okay, so what was the gradient of AB? Well, we've already worked it out, and it was 3 over x plus 3. Gradient of CD, we've already worked that one out. Gradient of CD is going to be, here we go, 1 over 3. We worked it out there. Okay, so I've already worked that out in number 1. Okay, so what I can do is I could either do a multiplication sum. So this gradient times this gradient has to be equal to -1. That's what we know. Product of the gradients has to be -1. And multiply numerator with numerator, denominator with denominator. Okay, and then I can either cross multiply or I can find an LCD. Okay, so your LCD would be 3x plus 3. Okay, so if you did that, you'd have 3 is equal to or if you cross multiplied, you would get straight away to this. 3 is equal to -3x plus 9. So we're going to subtract the 9 from both sides. So -6 is equal to -3x. We're going to finish dividing both sides by -3. So x is going to be equal to 2. So if you want perpendicular lines, A would have to be 2 and 5. You could also, with this one, if you didn't want to do this whole long equation thing, if I know that this is a gradient of AB, and I know this is a gradient of CD, sorry, 1 over 3. If AB is perpendicular to CD, then the gradient of AB must be equal to -3 over 1. Because if you invert it and change the sign, that's going to give you the gradient of AB. So I could do it that way as well. I could go 3 over x plus 3 is equal to -3 over 1. So 3 is equal to -3 times x plus 3. 3 is equal to -3x minus 9. Oh, I lost my sign there. Sorry, guys. So this should have been a -9, which is then going to be in plus and plus. Quickly redo this one. Apologies. So this is going to be 12 is equal to -3x. So you're going to end up having x is equal to -4. Okay, apologies. Okay, so with this one, we were saying we were going to invert it, which I did, and then I made I know the gradient of AB has to be equal to -3/1. I've made my equation, and now I'm busy solving it. That's how I worked out I was wrong on the last page. So when we divide by -3, there's my answer of x is equal to 4. So I prefer, instead of having a multiplication and a whole solve thing, I prefer to do it this way. And I just remember that perpendicular gradients, you're always going to invert and change the sign to get the perpendicular gradient. Okay, flip it, change the sign.